Hello, I'm Fabricio Hernandez, and I present the research work called Compressing Stress in Concrete Added with Recycled Aggregate and Textile Residues with Different Grinding Process. This work is made with many co-authors of the Universidad Michoacana de San Nicolás Hidalgo Faculty of Civil Engineering. The textile industry has led to high level of consumption and waste. This can cause a negative environmental impact since the textile industry and the clothing industry is one of the most pollution industries. Textile manufacturing is a chemical intensive process and requires a high volume of water throughout its operation. Seaweed and fiber waste are the main wastes generated during the textile production process, giving the ingress in post-consumer textile waste from people today, and finally its final disposal being incinerated or ended up in landfill causing leachate when combined with the other waste generated in homes. The materials that we use in the manufacture of the concrete samples for this experimentation: crushed gravel from Material Bank La Roca, volcanic sand from Material Bank Collitas, and recycled demolition aggregate from the old IMSS hospital and the Cerespo Morelia were used. The textile fibers were obtained from different grinding processes used by an industrial factory, from the clothing cut residues obtained from the textile industry located in the city of Moroleón. In this image, can see the different crushing process that the textile waste is subjected. We made 4 concrete mixtures of 6 concrete expansions were made in 10 cm of diameter for 20 cm of height cylinders. In all the mixture, 20% of gravel was replaced, but demolition concrete residue has aggregate there were tested at 7, 14, and 28 days of compression strength. The textile fibers were added 2% with the respect of the cement of the mixture. The characterization of the aggregates, the relation of the concrete samples, and the compression tests were carried using the official standards, and the end they could to see the accommodation of the textile fibers in the cylinder. We can see in this image the preferential accommodation in certain parts that the textile fibers had in the concrete specimens. The results indicate that the only control sample complete with the compression design, but the other mixture weighed around 90% of the design and 28 days. The 3 mixtures added with textile fiber have lower resistance to compression than the control mixture. Deduce that it was due to the preferential arrangement that the fibers had in the specimen. Also, we preparing the mixture, we moisten the textile fibers due to the absorption that the fibers present, and this could affect the water cement ratio, and with this the resistance to compression of the samples. Finally,